Scenario-based impacts of land use and climate changes on the hydrology of a forested catchment in Ghana, West Africa. 1 Dr. Michael S. Aduah, 2 Prof. GPW Jewitt and 3 Dr. Michele L.W. Toucher. 1 Geomatic Engineering Department. University of Mines and Technology. PO Box 237 Tarkwa, Ghana. 2 IHE Delft Institute of Water Education, Delft, the Netherlands. 3 South African Environmental Observation Network, Grasslands Wetlands Forests Node, PO Box 13053 Cascades, 3202, Pietermaritzburg, South Africa. Abstract: This study analyzed the separate and the combined impacts of climate and land use, LU, changes on hydrology of the Bonsa catchment in Ghana, West Africa, using the Agricultural Catchments Research Unit, ACRU, hydrological model. The study used 5 representative concentration pathway, RCP, 8.5 climate change scenarios, wet, 25th percentile, 75th percentile, dry and a multi-model median of 9 GCMs, from the CMIP5 AR5 models for near, 2020 to 2039, and far, 2060 to 2079, future time slices. Change factors were used to downscale the GCM scenarios to the local scale, using observed climate data for the control period of 1990 to 2009. The land use of 1991 was used to define baseline hydrological conditions, and 2011 land use, as well as 3 future land use scenarios: business as usual, BAU, economic growth, e.g., economic growth with enhanced reforestation, EGR, for 2 time slices, 2030 and 2070, were used. The study showed that under all separate climate change scenarios, overall flows for the major peak, wet, season reduced, but increased for both the dry and the minor peak, wet, seasons, but under combined climate and LU changes, stream flows increased. Under the combined scenarios, stream flow responses due to the different future LU scenarios were not substantially different. Additionally, LU appeared to be the dominant controlling factor in stream flow changes in the Bonsa catchment under a dry climate change, but under a wet climate change, climate controls stream flow changes. The spatial variability of catchment stream flow changes under combined LU and climate changes were greater than the spatial variability of stream flow changes under climate change. Keywords: Bonsa catchment, change factors, climate changes, Ghana, land use changes, spatial variability. Introduction. 19 CWRR. 2018, ACRU Theory Manual online, South Africa, available, cwrr.ux.ac.za. Web link accessed May 15, 2018. 20 D. Orgeval, T. and Palcher, J. 2008, Impacts of Precipitation Events and Land Use Changes on West African River Discharges During the Years 1951-2000, Climate Dynamics, 31, 2-3 249-262. 21 Dale, V.H. 1997, The Relationship Between Land Use Change and Climate Change, Ecological Applications, 7, 3753-769. 22 FAO. 2010, Global Forest Resources Assessment 2010, Main Report, Food and Agriculture Organization of the United Nations, Rome, Italy. 23 Forbes, Ka, Kienzl, S.W., Coburn C.A., Byrne, J.M., and Rasmussen, J., 2011, Simulating the Hydrological Response to Predicted Climate Change on a Watershed in Southern Alberta, Canada, Climatic Change, 105, 3-4 555-576. 24 Fowler, H.J., Blenkinsop, S., and Tebaldi, C., 2007, Linking Climate Change Modeling to Impact Studies, Recent Advances in Downscaling Techniques for Hydrological Modeling, International Journal of Climatology, 27, 12-1547-1578. 25 Graham, L.P., Anderson, L., Horan, M., Coons, R., Lumsden, T., Schultz, R., Warburton, M., Wilk, J., and Yang, W., 2011, Using Multiple Climate Projections for Assessing Hydrological Response to Climate Change in the Tequila River Basin, South Africa, Physics and Chemistry of the Earth, 36, 14-15 727-735. 26 Grappelli, B., Bacchiola, D., and Rosso, R., 2011, Spatial Downscaling of Precipitation from GCMs for Climate Change Projections Using Random Cascades, a Case Study in Italy, Water Resources Research, 47, 1 to 18. 27 Gaza, AC, Rufino, MC, Okas, S, Jacobs, S, and Noberga, RLB. 2018, Impacts of Land Use and Land Cover Change on Surface Runoff, Discharge, and Low Flows, Evidence from East Africa, Journal of Hydrology, Regional Studies, 15:49-67. 28 Hume, M, Doherty, R, Engara, T, New, M, and Lister, D, 2001, African Climate Change, 1900-2100, Climate Research, 17, 145-168. 29 IPCC. 2007, Climate Change 2007, The Physical Science Basis. Contribution of Working Group I to the Fourth Assessment Report of the Intergovernmental Panel on Climate Change, in, Solomon, S, Cheen, D, Manning, M, Chen, Z, Markey, M, Avreet, KB, Tigner, M. and Miller, H.L., eds. Cambridge University Press, Cambridge, United Kingdom, and New York, USA. 30 IPCC. 2013, Summary for Policymakers, in, Stocker, T.F., Cheen, D, Plattner, G.K., Tigner, M, Allen, S.K., Boskhung, J, Nowells, A, Siot, Y, Bex, V. and Midgley, P.M., eds, Climate Change 2013, The Physical Science Basis. Contribution of Working Group I to the Fifth Assessment Report of the Intergovernmental Panel on Climate Change, Cambridge, United Kingdom, and New York, USA. 31 Jallow, A, Fay, M.D., Roy Macaulay, H, Sarah May, P, Zugmar, R, Thomas, T.S. and Nelson, G.C. 2013, Overview, in, Jallow, A, Nelson, G.C., Thomas T.S., Zugmar R. and Roy Macaulay, H., ed. West African Agriculture and Climate Change, A Comprehensive Analysis, International Food Policy Research Institute, IFPRI, Washington, D.C., USA. 32 Kienzl, S.W., Nemeth, M.W., Byrne, J.M., and McDonald, R.J. 2012, Simulating the Hydrological Impacts of Climate Change in the Upper North Saskatchewan River Basin, Alberta, Canada. Journal of Hydrology, 412, 413, 2012 76-89. 33 Kim, J, Valisur, D, Madman, C.A., Goodale, C.E., Hart, A.F., Zimdars, P.A., Crichton, D.J., Jones, C., Niculin, G., Hewitson, B., Jack, C., Leonard, C. and Favre, A., 2013, Evaluation of the Cortex Africa Multi-RCM Hindcast, Systematic Model Errors, Climate Dynamics, 42, 5-6 1189, 1202. 34 Kunstmann, H., Schneider, K., Forkel, R., and Koch, R., 2004, Impact Analysis of Climate Change on an Alpine Catchment using High-Resolution Dynamic Downscaling of ECMAM 4x Slices, Hydrology and Earth System Sciences, 8, 6 1030, 1044. 35 Elode, Y, Mahet, G, Sum, B. and Tribolet, J.P. 2002, Analysis of a Sahelian Annual Rainfall Index from 1896 to 2000, The Drought Continues, Hydrological Sciences Journal de Sciences Hydrologiques, 47, 4563-572. 36 LeBlanc, M.J., Favreau, G., Mashuel, S., Tweed, So, Lwaro, M. and Capilera, B., 2008, Land Clearance and Hydrological Change in the Sahel, S.W. Niger, Global and Planetary Change, 61, 3-4 135-150. 37 Leaches, D., Abe, Ta, Valet-Kulam, C. and Abate, H., 2010, Streamflow Sensitivity to Climate and Land Cover Changes, Meki River, Ethiopia, Hydrology and Earth System Science, 14, 2010 2277-2287. 38 Li, Z, Lu, W, Zhang, X, and Zheng, F, 2009, Impacts of Land Use Change and Climate Variability on Hydrology in an Agricultural Catchment on the Loess Plateau of China, Journal of Hydrology, 377, 2009 35-42. 39 Lu, X, Koulibaly, P. and Evora, N, 2008, Comparison of Data-Driven Methods for Downscaling Ensemble Weather Forecasts, Hydrology, and Earth System Sciences, 12, 2615-624. 40 Lutz, A.F., Termott, H.W., Bymans, H., Shrestha, Ab, Wester, P., and Emirziel, W.W. 2016, Selecting Representative Climate Models for 55 Sood, A., Muthuwada, L. and McCartney, M., 2013, A SWOT Evaluation of the Effect of Climate Change on the Hydrology of the Volta River Basin, Water International, 38, 3297-311. 5610, J, Chou, FHS, Timbal, B, Wang, Y, Vase, J, and Wang, B, 2012, Assessment of an Analog Downscaling Method for Modeling Climate Change Impacts on Runoff, Journal of Hydrology, 472, 2012 111-125. 57 Thompson, J.R., Green, A.J., Kingston, D.G., and Gosling, S.N. 2013, Assessment of Uncertainty in River Flow Projections for the Mekong River using Multiple GCMs and Hydrological Models, Journal of Hydrology, 486, 0130. 58 Vidal, A.V., and Mishra, A.K. 2016, Water Security Assessment Using Blue and Green Water Footprint Concepts, Journal of Hydrology, 542,589-602. 59 Wang, G., and El Tahir, EAB. 2000, Role of Vegetation Dynamics in Enhancing the Low-Frequency Variability of the Sahel Rainfall, Water Resources Research, 36, 41013-1021. 60 Warburton, M.L., Schultz, Re, and Jewitt, GPW. 2010, Confirmation of ACRU Model Results for Applications in Land Use and Climate Change Studies, Hydrology, and Earth System Sciences, 14, 2010 2399-2414. 61 Warburton, M.L., Schultz, Re, and Jewitt, GPW. 2012, Hydrological Impacts of Land Use Change in Three Diverse South African Catchments, Journal of Hydrology, 414-415, 2012 118-135. 62 Shwe, YK. 1997, Biosphere Feedback on Regional Climate in Tropical North Africa, Quarterly Journal of the Royal Meteorological Society, 123, 542 1483-1515.